Welcome to 11.1, Systems of Linear Equations. We're going to look at substitution and elimination. So we're going to solve systems of equations by substitution and by elimination, identify inconsistent systems of equations containing two variables, express the solution of a system of dependent equations containing two variables, solve systems of three equations that contain three variables, and then do the same things, identify inconsistent systems that contain three variables, and express the solution of a system of dependent equations containing three variables. So we're going to work in two variables and three variables using substitution, elimination. We're going to identify inconsistent systems, and then when we see a dependent system, we will express it using equations. So let's start by solving each system of equations. I'm going to solve one way. There are multiple ways to solve. If you solve it a different way and you get the same answer, that's totally fine. So we have 2x minus y equals 3 and 5x plus 4y equals 40. What I'm going to do is solve for y. So y equals 2x minus 3, and then I'm going to substitute that back in. So we have 5x plus 4, and y I'm going to rewrite as 2x minus 3 equals 40. And then let's distribute. 5x plus 8x minus 12 equals 40. Then we have 13x minus 12 equals 40. If we add 12 to both sides, 13x equals 52. And then divide by 13. X equals 4. And then we'll plug that back into the first one. Y equals 2 times 4 minus 3. So 8 minus 3 is 5. Let's check it. So if x is 4, 2 times 4, and y is 5 minus 5, it needs to equal 3. 8 minus 5 equals 3, that checks. Then we have 5 times 4 plus 4 times 5 equals 40. 20 plus 20. 20 plus 20 equals 40. Awesome. Okay, so that checks it. Our answer is 4, 5. Next, we have 3x plus y equals 10 and 9x plus 3y equals 13. I'm going to start by rewriting the top multiplied by 3. So I'm just going to multiply the whole equation by 3. So that way it's 9x plus 3y equals 30. And then the bottom stays the same. 9x plus 3y equals 13. And I'm going to subtract these two equations. So 9x minus 9x gives me 0x. 3y minus 3y gives me 0y. So I have 0 on this side. 30 minus 13 is 17. Now we have a weird situation here. 0 equals 17. We know that's not true, so this is no solution. Zero cannot equal a number because it's 0. Okay, next we have x plus 2y equals 4 and 7x plus 14y equals 28. So I'm going to do the same thing I did last time and multiply the top equation by 7. So that way I have 7x plus 14y equals 28. The bottom stays the same, 7x plus 14y equals 28. And now we have the same exact equation twice. This tells me there's infinite solutions because they're the exact same line. And so let's solve for x. So let's start back here and find out what is x. X is negative 2y plus 4. And y can be anything, so we'll just put y equals r. Y equals any real number. And there we go. This is a infinite solution problem because y can be anything, and then we get x. Okay, now we're going to work with 3 equations with 3 variables. So this is just, again, one way to do it. This is the way I did it. Doesn't mean that it's the only way. There are multiple ways to solve these, and if you get to the same right answer, then awesome job. So from here, what I'm going to do is I'm going to add the second row to the third row and rewrite the third row with the sum of the second row and the third row. So the top row, the first row, I'm going to leave the same, x minus 3y plus 4z equals 19. The second row I'm also going to leave the same, 2x plus y plus z equals 3. But if I add 2x minus 2x, I get 0. Y plus 3y is 4y. And z minus 3z is minus 2z. 3 minus 17 is negative 14. So we have a new third row. Next, I'm going to multiply the first row by 2. And at the same time, I'm going to multiply the middle by a negative. So that way they're opposites. You could multiply the top by negative 2, but I just like having the top be positive and stay there. So I don't want to eliminate anything. That's just a personal preference, though. It's not any kind of like mathematical thing. I just prefer it to stay there. So the top multiplied by 2 is 2x minus 6y plus 8z equals 38. And the middle row multiplied by a negative makes it negative 2x minus y minus z equals negative 3. And then the bottom we are leaving the same for now. 4y minus 2z equals negative 14. And then I'm going to add the first row to the second row, so that way it eliminates. So the first row stays 2x minus 6y plus 8z equals 38. And then we'll have 2x minus 2x, 0, negative 6y, and negative y is negative 7y. 8 minus 1 is 7z, and 38 minus 3 is 35. Again, we didn't do anything to the bottom, so it just tags along. 4y minus 2z equals negative 14. Now I'm going to divide the middle by 7. It looks like everything's a multiple of 7. So the top I'm going to leave 2x minus 6y plus 8z equals 38. And then if I divide everything in the second row by 7, I have negative y plus z equals 5. And I'm also going to divide the third row by 2. So we have 2y minus z equals negative 7. And then I'm going to multiply the middle row by 2, so that way we can start eliminating there. So the top stays 2x minus 6y plus 8z equals 38. The middle will be negative 2y plus 2z equals 10. And the bottom, if we added negative 2y plus 2y, we get 0. 2z minus z would leave us with just z, and 10 minus 7 is 3. So we have z is 3. So now let's plug that into the middle row. We'll have negative 2y plus 2 times 3 equals 10. Negative 2y plus 6 equals 10. Subtract 6. Negative 2y equals 4. Y equals negative 2. Then we've got, let's plug that back into both of them into the top. So we have 2x minus 6 times negative 2 plus 8 times 3, and that equals 38. So we have 2x minus plus 12 plus 24 equals 38. So 2x plus 36 equals 38. 2x equals 2. X equals 1. And now that we have all three values, we need to check our answer. So we'll check the first one. We go 1 minus 3 times negative 2 plus 4 times 3 needs to equal 19. 1 plus 6 plus 12 equals 19, and yes, that checks. Next we have 2 times 1 plus negative 2 plus 3 equals 3. 2 minus 2 plus 3 equals 3, that checks. And we need negative 2 times 1 plus 3 times negative 2 minus 3 times 3 to equal negative 17. Negative 2 minus 6 minus 9 equals negative 17, so that checks too. So we have our answer, and that is 1, negative 2, 3. Okay, let's solve another one. So for this one, the first thing I'm going to do is multiply the first equation by a negative 3. So we will have negative 3x plus 3y plus 3z equals negative 12. And then the second and third row is going to stay. So we have 3x plus 4y plus z equals 4, and 12x plus 9y equals 0. And then if I add the first row to the second row, and we'll have a 0x, so the bottom's going to stay 12x plus 9y, no z, equals 0. The middle, if I add negative 3 plus 3, we'll have 0. 3y plus 4y is 7y. And then 3z plus z is going to be a 4z. And negative 12 plus 4 is negative 8. And then the top row, instead of leaving it, I'm gonna multiply it by negative. That way it's positive again. So we'll have 3x minus 3y minus 3z equals 12. And then in order to get rid of that 12x, we'll have to multiply the top by a negative 4. So we'll have negative 12x minus 16y minus 4z equals negative 16. Middle stays 7y plus 4z equals negative 8. And then we're going to eliminate that 12x 9y equals 0. So if I do the same thing I did before where I add, and then after I'm done adding, I multiply by negative to make it positive again, we'll have 12x plus, oh, you know what, actually, oh no, I'm going to, instead of that, I'm gonna move this equation to the top because the z is already eliminated in this equation, so it's gonna make it a lot easier for solving. That's gonna be my top equation now. My middle equation is gonna stay the same. And then the top equation, since we added 12 minus 12 is 0, 9 minus 16 is negative 7, and 0 minus 4 is negative 4. And then 0 minus 16 is negative 16. Now we can add the second to the third row. So we will get 12x plus 9y equals 0. 7y plus 4z equals negative 8. And then 7 minus 7 is 0. 4 minus 4 is 0. So we have 0 equals negative 16. Do you remember what happens when we have 0 equals a number? We will have, oh wait, not 16, it'll be 24. When we have 0 equals a number, this is no solution. Okay, next we have another 3 variable with 3 equations. So let's start by adding the first equation to the second one. That way we eliminate the x's. So the first will stay the same, x minus y minus z equals 1. x minus x is going to be 0. 2y minus y is going to give us just a y. Negative 3z and negative z is negative 4z. And negative 3 and 1 is negative 2. In the bottom, we have 4x minus 3y minus 8z equals 2. Now we want to eliminate that 4x, so let's multiply the top by 4x minus 4y minus 4z equals 4. We got y minus 4z equals negative 2. And then I'm going to multiply the bottom by a negative, so that way they're already opposites. Minus 4x plus 3y plus 8z equals negative 2. Then we have 4 minus 4 is 0. Negative 4 plus 3. So the top will stay 4x minus 4y minus 4z equals 4. The middle will stay as well. Y minus 4z equals negative 2. And then we have negative y and negative 4 plus 8 plus 4z. And then we have 4 minus 2 is 2. And these two equations are the same if we multiplied out a negative. And since we have two of the same equation, we have another infinite solutions problem here. This is also known as the dependent. So what we'll do is we'll solve for the variables until they all have something in common. It looks like they all have a z. So what we'll do is we'll solve in terms of z. So if I start with let's start right here. Y minus 4z equals negative 2. So y minus 4z equals negative 2. That means that y equals 4z minus 2. So that's my y. My x is going to be, let's go way back over here. Let's use that one. So we have x minus, and we know what y is. Y is 4z minus 2 minus z equals 1. So we have x minus 4z plus 2 minus z equals 1. X minus 5z equals negative 1. So x equals 5z minus 1. And so we have y equals 4z minus 2, x equals 5z minus 1. Z can be anything, so z is r. Okay, we'll look at some application problems. The perimeter of a rectangular floor is 180 feet. Find the dimensions of the floor if the length is 5 times the width. So we have a rectangle, we have width, we have length, and length is 5 times the width. And the perimeter, if we add up all the sides, it's 180 feet. So using this information, let's find out what the dimensions are. So perimeter, we know if we take the width and add it to the length and the length, we'll get 180. We also know that the length is 5 times the width. So since L is 5W, let's plug that in to this other equation here. So we'll have 2 W plus 2, and L is 5W, and that equals our perimeter. So we have 2W plus 10W, which is 12W. And if we divide by 12, W is 15. And we can just find out what the L is now. L is 5 times 15, so L is 75. So it is 15 by 75, or 15 feet by 75 feet. There we go. 4 large cheeseburgers and 3 chocolate shakes cost a total of $7. 3 shakes cost 50 cents more than 1 cheeseburger. What is the cost of a cheeseburger and what is the cost of a shake? I don't know, but I am starving and this sounds delicious and affordable. So let's write this out. 4 cheeseburgers and 3 shakes are $7. And 3 shakes are 50 cents more than a cheeseburger. This tells us, if we rewrite this, this would be C equals 3S minus 0.5. So let's substitute that in. So we've got 4 times our C, which is 3S minus 50 cents, plus 3S equals $7. So we have 12S minus 2 plus 3S equals 7. We have 15S equals 9. S equals 9 over 15, which in money is 60 cents. Then we can use this and plug it into our C equation. 60 cents minus 50 cents. So this is $1.80 minus 50 cents. Okay, so cheeseburgers cost $1.30 and shakes cost 60 cents. Cool. Okay, our last example for today. Find a, b, and c so that the graph of the function y equals ax squared plus bx plus c contains these points, negative 1, 3, 3, 8, and 0, 2. So if we plug these points in, everywhere we see an x and a y. So y 3 equals a negative 1 squared plus b negative 1 plus c would give us 3 equals a minus b plus c. And then we've got 8 equals a 3 squared plus b times 3 plus c. So 8 equals 9a plus 3b plus c. And then we also have 2 equals a times 0 squared plus b times 0 plus c. So 2 equals c, which is super cool. Okay, so now let's solve for the rest of them. I'm going to start here. So we have 3 equals a minus b plus c. But I know what c is. I know that c is 2. 3 equals a minus b plus 2. And if I subtract the 2 over, a minus b equals 1. And now let's do this one. We've got 8 equals 9a plus 3b plus c. And we know c. 8 equals 9a plus 3b plus 2. And if we subtract the 2, we get 9a plus 3b equals 6. So this is what we're going to use. And we're going to solve these equations to get a and b. So a minus b equals 1. 9a plus 3b equals 6. So what I'm going to do is I'm going to multiply the top by 3 because then I can eliminate the b value. So I have 3a minus 3b equals 3. 9a plus 3b equals 6. And that's going to give us, if we eliminate the b, then we'll have 3a minus 3b equals 3. And then we have 9 plus 3 is 12a. 3 minus 3 is 0. And 6 plus 3 is 9. So 12a equals 9. That means that a equals 9 over 12, which is 3/4. And then we can plug that in for b, so we have we're plugging it in here. I lost my place for a moment. I'm sorry. So we have 3 times 3/4 minus 3b equals 3. So we have, if we divide everybody by 3, we just have 3/4 minus b equals 1. So b is 3/4 minus 1, which is negative 1/4. And then it's a good idea to check. I already used green, so I guess we'll check it in pink. So we'll check 3/4 minus -1/4 plus 2 equals 3. 3/4 plus 1/4 plus 2 equals 3. That checks. Then we have 9 times 3/4 plus 3 times -1/4 plus 2 needs to equal 8. So 27/4 minus 3/4 plus 2. So we have 24/4 plus 2. That checks. And so, yeah, because the third one was just c equals 2. Our answer is 3/4 -1/4 2.